Today we want to talk about average speed and average velocity. So what does average speed mean? So how often have we encountered situations in which an object travels always at the same speed? Very rarely. Okay, so you could travel at the same speed for a small time interval and then switch your speed to some other value and so on and so forth. So when your speed changes, it is useful to define a quantity called as average speed, which can just be defined as the total distance traveled divided by the total time taken. So it's just like your grades. At the end of the year, you have your average grade reported from all the grade points that you earned in the total time of 1 year. So let's take a simple example. Let's say we have a car that is driving at 40 miles per hour for the first half an hour and then switches to 60 miles per hour for the next 1.5 hours. What is the average speed of this car? Or you're tempted to say that it is 40 plus 60 divided by 2, which is 50 miles per hour. Let's just think about that. If the driver traveled at 60 for about 1.5 hours and he traveled at 40 only for half an hour, shouldn't his average speed be closer to 60 than to 40? So, therefore, we cannot do mathematical average if these speeds are not weighted at equal time intervals. So, we need to find the total distance and divide it by the total time so that we can see what speed he averaged over the entire trip. So, if you know the speed and you know the time, we do know how to calculate the distance. We know that distance equals speed times time. So 40 times 0.5 gives us 20 miles. We can even think of it as if in 1 hour he travels 40 miles, half an hour he's going to travel 20. The same way, distance equals speed times time. So in the second half of the trip, he's going to do 60 miles per hour times 1.5 hours, which gives you 60 times 1.5, 90 miles. So in all, we can say average speed is total distance over total travel. So I can write it as an equation as d1 plus d2 divided by t1 plus t2. So the distance traveled in the first part is 20 miles. The second part is 90 miles. So total distance is 20 plus 90. The first part took a time of 0.5 hours. The second part took a time of 1.5 hours. So therefore the total time is 2 hours, so it is 110 miles over 2 hours, which is 55 miles per hour. So this will be the average speed of the car for the entire trip. Let's look at another problem with a little more data. So let's say Jane here is driving back home from her college. So she first takes the inroads, which is rather slow speed. So she drives at 40 miles per hour for about, let us say, 30 minutes. And then she speeds up once on the highways to 60 miles per hour. And she drives for about 45 miles at that speed. Then she stops for 10 minutes to get some coffee. So not moving at all. And then she continues for the next, let us say, 20 miles, the last stretch to home. And she completes this 20 miles in about, say, 35 minutes. So we want to compute the average speed of Jane for the entire trip. Remember, we cannot do speed 1 plus speed 2 plus speed 3 divided by 3 because they are weighted for different time intervals. So we have to compute the total distance and divide it by the total time. So I'm going to put this into a chart just so that, these numbers are kind of easy to follow. So let's make a chart, distance times speed. So we have in the first part, she traveled at 40 miles per hour for 30 minutes, and we know 30 minutes is going to make 0.5 hours, and I want to keep this in hours to be consistent with the units of speed. And the second part, she travels at a speed of 60 miles per hour, and we know the distance given is 45 miles. The third part, she is not moving at all, so 0 miles per hour and 10 minutes. We want to convert 10 minutes to hours, so divide by 60, which will give us 10 divided by 60, which is going to be 1/6, which is 0.167 hours. Wrote it in the wrong place. So 0.167 hours. And then the last part, she covers a total distance of 20 miles in 35 minutes. So let's convert 35 minutes to hours, which is 35 divided by 60. So that'll be 0.58 hours. Or to be exact, 0.583 hours. So now that we have the data, we can see that if I can solve for the distance in these two parts and the time in this part, then I can do total distance over total time. So we're going to do just that. And we know we can compute distance if we know speed and time as simply distance equals speed times time. So that'll be 40 miles per hour times 0.5 hours, and that'll be 40 times 0.5, which will be 20 miles. The same way, with this we know that if he's not moving at all, then 0 miles. Here we want to solve for the time, and we know time is distance divided by speed, so that will be 45 divided by 60, and guess how much time that will be? Yes, because it's 3/4 of that, so it's going to be 0.75 hours. Now all we need to do is compute the total distance, which we can see here is 20 plus 20 plus 45. That will be about 85 miles is what she traveled in total. And how much time did this take her? This took her about, let's compute, add up all the times, 0.5 plus 0.75 plus 0.167 plus 0.583. Turns out to be exactly 2 hours. And therefore her average speed for the entire trip will be 85 miles over 2 hours, and that will be 42.5 miles per hour. So this is how we can compute the average speed for her. What about average velocity? Average velocity is going to be total displacement over total time, which means that we need to know the direction of motion for each segment. So let's take a situation wherein I have a car that traveled in a straight line for about 40 kilometers in, say, about 0.3 hours. And then it came back about halfway, 20 kilometers, and it took about 0.2 hours, let us say. And if I want to compute the average velocity, I need the total displacement. If I were to do a similar table or a chart, then in this case I would do displacement, time, and velocity. So in the first part of the trip, the displacement is 40 kilometers in the forward direction. I'm going to take that as positive, and the time is 0.3 hours. And I don't need to calculate the speed of this part. And then the second part, the distance is 20 kilometers, but displacement is in the opposite direction. So if I take this as positive, I need to give this a negative sign because it's in the opposite direction. So displacement is negative 20 kilometers and the time is 0.2 hours. So if you think about it, even though the total distance traveled is 60, the displacement is merely start to finish, so that will only be 20 kilometers in the positive direction. Looking at the chart, we can also get the same result, 40 minus 20, so it's 20 kilometers and 0.5 hours. So that means the displacement of the car has just been 20 kilometers in 0.5 hours. So the average velocity would simply be 20 kilometers divided by 0.5 hours, which will just be 40 kilometers per hour. So to recap, average speed is the total distance over total time. It will only be the mathematical average if it is weighted in equal time intervals, or if your velocity is increasing at the exact same rate every single second of time. When you do average velocity though, direction is important, so total displacement over total time gives average velocity. Until next time.